Welcome back, everybody, for another deep dive. This time, we're going to be talking about large language models.
LLMs.
LLMs, yeah. But with a twist.
Okay.
We're not just talking about making them bigger.
Mm-hmm.
We're talking about making them smarter. And
Yeah.
we're going to be looking at a research paper titled Weighted Reward Preference Optimization for Implicit Model Fusion.
It's mouthful, but it's a really fascinating paper.
Yeah, it is.
I think what's really interesting here is this paper is looking at how to combine the strengths of multiple LLMs.
So, like, imagine you've got all these, like, brilliant AI minds, right? Each with their own specialties.
Yeah.
But, like, getting them to work together effectively,
That's a challenge.
it's a real challenge.
It is.
Yeah.
That's the issue that a lot of researchers are dealing with right now.
Mm-hmm.
Because, existing LLMs are trained on different data sets.
Right.
They have different architectures.
Yeah.
And the current methods for combining them are often very computationally expensive or limited in scope.
Okay, so you mentioned, like, model ensembles and mixtures of experts.
Right.
What makes those approaches, like, less than ideal?
Well, so ensembles, right? You're essentially running multiple models at the same time,
Mm-hmm.
which can be very computationally heavy.
Yeah.
Mixtures of experts try to specialize different parts of a single model,
Mm-hmm.
but that can be really tricky to implement effectively.
Right.
And then you have model merging, but that's often restricted to models with identical architecture.
Oh,
So it's like
Yeah.
trying to fit puzzle pieces together from different sets.
gotcha.
They don't quite work.
So it's not as simple as just, like, taking the best parts of each model and, like, stitching them together Frankenstein style.
It would be nice, wouldn't it,
Yeah.
if it were that simple?
Yeah.
Unfortunately not.
Okay.
That's where implicit model fusion comes in,
Okay.
or IMF.
I am.
So instead of directly merging the models, IMF focuses on training a single LLM,
Okay.
and that's the student, to learn implicitly from the outputs of other, more specialized LLMs.
So the teachers.
The teachers, exactly.
Oh, okay.
So it's like having a student learn from the works of master artists
Oh, yeah.
rather than trying to merge the artists themselves.
Right.
Does that make sense?
That's like a great analogy. Yeah.
Yeah.
Yeah, I like that.
So an IMF really leverages this idea of preference optimization.
Okay.
So the student LLM is trained to prefer outputs that are considered better, according to a reward model.
Interesting.
So it's sort of subtly nudged towards the expertise of the teachers
Oh, okay.
without explicitly copying their structure.
Right. Right.
That makes sense.
That makes sense.
Yeah.
But as we know, like, different experts might have different like styles or preferences.
Absolutely.
Right.
Yep.
How does IMF handle that potential conflict?
So that's a great point.
Yeah.
And it's one of the key challenges that the paper highlights.
Okay.
They actually did an experiment with the ultra feedback data set
Mm-hmm.
and the arm-around reward model.
Okay.
And what they found was different LLMs had significantly different preferences in terms of what constitutes a good response.
Okay, so, like, how do you bridge that gap? How do you teach the student to learn from teachers with contrasting styles?
This is where I imagine WRPO comes in, right?
Yes, exactly.
Okay.
So weighted reward preference optimization,
WRPO.
or WRPO,
Yep.
is the innovation
Okay.
presented in this paper.
Gotcha.
It acts as a sort of mediator between the student and the teachers,
Okay.
using this clever two-stage process.
Okay, break it down for us.
Yeah.
What are those two stages?
So first, WRPO creates what's called a preference data set,
Okay.
where the student is initially guided to prefer its own outputs that are similar to those preferred by the source LLMs.
Interesting.
So it's kind of like easing the student into a new way of thinking
Okay.
by starting with something familiar.
Right.
And then in the second stage,
Yeah.
WRPO gradually shifts the weight.
Encouraging the student to align more and more with the preferred outputs of the teachers.
Interesting.
And this is what they call the progressive adaptation strategy.
Oh, okay. So it's a gradual process of
Right.
aligning the student with the expertise of the teachers.
Yeah.
And the paper also mentions a fusion coefficient.
Right.
What role does that play?
So that's, you might see it as alpha in the equation.
Okay.
Think of it like a knob
Yeah.
that controls the influence of the teachers.
Okay.
So by adjusting this coefficient,
Yeah.
you can fine-tune the learning process.
Interesting. And
Yeah.
you mentioned IPO and SIMPO earlier.
Yes.
How do those fit into all of this?
So those are actually alternative preference optimization objectives.
Okay.
So think of them as different coaching styles
Gotcha.
for the student.
Right.
And what's really cool about WRPO is that it's proven to be very adaptable to these different coaching methods,
Oh, wow.
which is really promising
Yep.
in terms of its versatility.
So in a sense, like WRPO provides this flexible framework for guiding an LLM to learn from the best of its
Cheers.
peers. Yeah.
Yeah, absolutely.
But does this actually translate to real world performance improvements?
That's the million-dollar question, right?
Yeah.
So that's what we'll delve into next.
Okay.
The researchers put WRPO to the test. They use some really rigorous benchmarks,
Okay.
and the results are quite compelling.
Awesome.
So that's what we'll talk about after the break.
All right. Sounds good.
Yeah.
We'll be right back.
Okay, so picking up where we left off,
Okay.
those rigorous benchmarks.
Yeah.
They actually tested WRPO on 3 different benchmarks.
Okay.
MT Bench, Alpacable 2,
Okay.
and Arena Hard.
Okay.
These are all designed to assess how well LLMs follow instructions.
Okay. So, like, pretty challenging test.
Yeah.
What were the key findings?
So WRPO consistently outperformed other methods across all 3 benchmarks.
Oh, wow.
And this includes methods that relied on much larger
Okay.
and more computationally intensive models.
So size isn't everything in the world of LLMs.
It seems that way, yeah.
Interesting.
And specifically on Alpacable 2,
Okay.
a WRPO-enhanced Llamo model, despite being relatively small, outperformed significantly larger models.
Wow.
Its link-controlled win rate was 55.9%
Okay.
against GPT-4 Preview 1106.
That's pretty remarkable.
It is, yeah.
It suggests that like WRPO can help kind of level the playing field a little bit.
Yeah, I think that's a great point.
Right. Making advanced AI capabilities accessible to like a wider range of users.
Exactly. Because if we can achieve similar or even better performance with smaller models,
Right.
then it opens up AI development to those who might not have access to vast computational resources.
Yeah, exactly. I mean, that's huge.
Yeah.
I'm really fascinated by this idea of like making powerful AI more accessible. Are there other ways that WRPO might contribute to that?
So scalability is another key factor here.
Okay.
The researchers found that WRPO effectively scales with the number of source LLMs.
So more teachers, essentially.
More teachers, exactly. So the more teachers you have, the greater the potential for knowledge integration and learning.
That's pretty cool. So
Yeah.
you could like tap into the combined knowledge of like dozens or even like hundreds of specialized AI models.
Hypothetically, yeah.
Right.
That's
Yeah.
the potential we're talking about.
So like a global brain trust, essentially.
Yeah, I like that. A global brain trust of AI.
Yeah. Well, what are some of the like challenges in building a system like that?
Well, one of the big challenges would be
Yeah.
managing and curating the outputs of all of those different LLMs.
Right.
Making sure that they're compatible
Yeah.
and organized in a way that facilitates effective learning.
So it's not just about like connecting the models, it's about like creating a structured learning environment.
Yes.
Like
Yeah.
creating a curriculum
Right.
for the AI.
And of course, like ensuring the quality of the
Absolutely.
information being shared.
Yeah, we want to make sure that the teachers are providing accurate and unbiased knowledge.
Right. You don't want to build a system where AI models are learning from like flawed information.
Exactly.
Okay.
Garbage in, garbage out.
Yeah, exactly.
So, yeah, there are definitely some really exciting possibilities with WRPO. But there are also important considerations to address as we move forward.
So like what are the limitations of this approach?
Okay, so that's a great question.
Yeah.
No technology is perfect, obviously.
Right.
So one of the main limitations that they acknowledge is that WRPO currently only utilizes the highest scoring response from each source LLM.
So it's like focusing solely on the valedictorian of each class.
Yeah,
Right. Ignoring the unique contributions of other students.
that's a great analogy. Even those who might have valuable insights.
Absolutely. Yeah.
Right.
There's a potential for overlooking valuable information
Right.
by only focusing on those top-rated responses.
Okay, so like, how do we ensure that we're not like discarding potentially valuable knowledge
Right.
in the pursuit of those like best answers?
That's a great question.
Yeah.
And that's where future research comes in.
Okay.
Maybe we can develop more nuanced methods that consider multiple responses
Okay.
or even incorporate multiple reward models to capture a broader spectrum of expertise.
So it sounds like WRPO is just the first step towards like a much richer understanding of how AI systems can learn and evolve.
I think so, yeah.
Yeah.
It's definitely opened up a new avenue for exploring collaborative learning in AI. It'll be fascinating to see where this path leads.
It really will.
Yeah.
Okay, so we are nearing the end of our deep dive.
Okay.
Before we wrap things up, is there anything else about WRPO's limitations that we should discuss?
Yeah, there are a couple more points worth mentioning.
Okay.
So the paper also points out that WRPO's inner workings aren't yet fully understood from a theoretical standpoint.
So we have this like remarkable technology,
Yeah.
but we're still figuring out exactly how all the gears and levers operate at a fundamental level.
Exactly. It's kind of a black box still.
Right.
And then finally,
Yeah.
the researchers acknowledge that while WRPO has shown really promising results in controlled settings,
Right.
more work needs to be done to assess its performance in real-world applications.
Okay, so it's like moving from the lab to the field,
Exactly.
where the conditions are more complex and unpredictable.
Exactly, yeah.
Yeah.
That's a great way to put it.
So what are some of the challenges in like making that transition?
Or one of the big ones
Yeah.
is ensuring that the teachers are providing high-quality, reliable information.
Okay.
In a research setting,
Yeah.
you can carefully curate the data, control the variables,
Mm-hmm.
but in the real world,
Yeah.
things are much messier.
Yeah. Things are a lot messier. You
Yeah.
can't always guarantee like the accuracy or the objectivity
Right.
of the information that the AI is learning from.
Exactly.
Right.
So what steps can we take to address that?
Yeah. I mean, that's a big question.
It is a big question.
Yeah.
I think that's where robust data validation and verification processes come in.
Okay.
We need to develop mechanisms for evaluating the trustworthiness
Okay.
of the source information
Mm-hmm.
and filtering out potentially biased or inaccurate data.
So it's not just about connecting the AI models. It's about building like safeguards to ensure that the knowledge being shared is reliable.
Exactly.
Yeah.
And I think as we move towards deploying WRPO in real-world systems, ethical considerations become paramount.
Right. That brings us back to, this idea of responsible AI development.
Absolutely.
We need to ensure that these systems are like aligned with human values.
And used for the benefit of society.
I completely agree.
Right.
Yeah. As WRPO and other AI technologies continue to advance, it's our collective responsibility to guide their development and ensure that they serve humanity's best interests.
It's been incredible exploring the world of WRPO.
Yeah, it has.
We've learned about its potential to revolutionize AI learning, its limitations,
Yeah,
and the exciting possibilities that lie ahead.
absolutely. It's a very exciting field right now.
It really is.
Yeah.
And I think those conversations about responsible AI development and the ethical implications are crucial as we kind of navigate this uncharted territory
I agree.
of rapidly evolving technology.
It's moving fast.
It is moving fast.
Yeah.
Well, thank you so much for joining us on this deep dive.
Thank you for having me.
And until next time,
Yes.
keep exploring, keep questioning, and keep learning.
Couldn't have said it better myself.
We're back for the final part of our deep dive on WRPO.
It's been a journey exploring this innovative approach to AI.
Yeah.
I mean, we've covered the underlying concepts. We've talked about its potential impact and even some of its limitations.
Absolutely.
You mentioned that researchers they identified a need for a more robust theoretical understanding of how WRPO works.
Right.
So what are some of the key questions that still need to be addressed?
Well, one of the most intriguing questions, I think, is how the student LLM actually integrates the knowledge from the teachers.
Okay.
We know it's guided by the reward model to prefer certain outputs,
Right.
but the underlying mechanisms of that whole process are still being explored.
So it's like we've observed that the student is learning, but we're still unraveling the mysteries of how that learning is happening.
Exactly.
At a cognitive level.
At a cognitive level, yeah.
That's a great way to put it.
And this deeper understanding could be really crucial
Yeah.
for refining WRPO, troubleshooting potential issues,
Okay.
and adapting it to new challenges.
It seems like this would require collaboration across different disciplines, not just computer science.
I think so, yeah.
Right.
I mean, insights from fields like cognitive science, neuroscience, even linguistics,
Yeah.
those could all shed light on how AI systems process and integrate information.
It's fascinating to think that we might learn something about human intelligence
Yeah.
by studying how AI systems learn.
It's a very interesting feedback loop.
Yeah, it is.
Yeah.
But let's shift gears for a moment. We've talked about the need for further research,
Hmm.
but what about the practical implications?
Right.
How do we move from like theoretical exploration to real world applications?
I think that's where the focus needs to shift now.
Okay.
The researchers acknowledge that while WRPO shows a lot of promise in these controlled experiments,
Uh-huh.
um, its performance in real-world scenarios needs to be rigorously evaluated.
So it's like moving from the lab to the field,
Moving the lab to the field, yeah.
where the conditions are more complex, more unpredictable.
Less controlled.
Yeah, a lot less controlled.
Yeah.
What are some of the challenges in making that transition?
So one challenge is ensuring that the teachers are providing high-quality, reliable information.
Okay.
Because in a research setting, you can really carefully curate the data
Yeah.
and control the variables, but in the real world, things are a lot messier.
You can't always guarantee the accuracy or the objectivity of
Well,
the
yeah.
information that the AI is learning from.
Yeah, that's a huge challenge.
What steps can be taken to address that?
So I think that's where robust data validation and verification processes become really important.
Okay.
Developing mechanisms for evaluating the trustworthiness of the source information and filtering out potentially biased or inaccurate data.
So it's not just about connecting the AI models, it's about building like safeguards to ensure that the knowledge being shared is reliable.
Exactly.
Yeah, it's like creating a network of trust essentially between these models.
Yeah, absolutely.
And as we move towards, deploying WRPO in real world systems, ethical considerations become really important.
Absolutely. Yeah, I completely agree.
We need to ensure that these systems are aligned with human values and used for the benefit of society.
Couldn't agree more.
It's been an incredible journey exploring the world of WRPO.
It really has.
We've learned about its potential to revolutionize AI learning. We talked about its limitations and the really exciting possibilities that lie ahead.
Absolutely.
It's clear that WRPO is not just a technological innovation. It's a catalyst for deeper conversations about, the nature of intelligence, the future of learning, and the ethical implications of, increasingly powerful AI systems.
For sure.
And those conversations are crucial.
Absolutely.
As we navigate the uncharted waters of this rapidly evolving technological landscape.
You're moving fast.
It is moving fast.
Yeah.
Well, thank you so much for joining us on this deep dive into WRPO.
Thanks for having me. It was great to be here.
And until next time, keep exploring, keep questioning, and keep learning.
Couldn't have said it better myself.